Okay, welcome back. In the previous lecture, we have talked about the BC normal form. We provide a definition of BC normal form to check if a relation is in the BC normal form or not. We provide you with a checking condition, right? If you still remember the definition, whenever we can find an FD like A implies B, then the head of the FD should be a superkey of the relation. If so, then we can say this relation is in the BC normal form. Otherwise, we can reject it, right, and say it is not in the BC normal form. In the case if a relation is not in the BC normal form, we'll provide you with a decomposition algorithm, right, to decompose the relation into smaller ones and to make them all in the BC normal form. We provide you with the decomposition algorithm already, and you must wonder if the decomposition is good or not. So in this page, we can find some problems with the existing decompositions because the decomposition algorithm we provided before may have some problems. So here we can introduce a new concept is called lossless decomposition. So formally, if we can find a decomposition and we can say it is lossless if we can recover the original relation based on the decomposed new relations. Let's assume we have an existing relation R with A, B, C as attributes. With the previous decomposition algorithm, we can decompose this R into R1 and R2. Right. And if we plan to further recover this R based on R1 and R2, with some recovery algorithm or joins based on the R1 and R2, we can get the R prime with A, B, C as attributes. If this R prime equals to R, then we can say this decomposition here is lossless because we can precisely recover the original relation based on these new relations we decomposed. However, in the real world, this decomposition can be lossy because this R prime normally is larger than R, right? Because according to the previous knowledge we learned, this R prime can be derived based on joins between the R1 and R2 with shared common attributes, and we will introduce some new redundant or non-existing data tuples in the original relation in this R prime. We will show you with the example what we mean here. This R prime is normally larger than R. And in some cases, if we can make sure this R prime equals to R, then we can say it is lossless. And normally we want to make sure it's R prime equals to R, right? Because if we plan to do some queries based on these new relations, and we may have to join them together to do the queries, we don't want to introduce some non-existing data tuples in this R prime in the queries, right? Therefore, we need to must ensure this R prime equals to R. And let me provide you with an example in this page about a lossy decomposition. Let's assume we have a relation with A, B, C as attributes, and we also have three data tuples as shown in this table. And we can find some FDs, A implies B, C implies B. Therefore, we can find this relation is not in the BC normal form. And we can have a decomposition like this. We can decompose this larger table into two tables, A and B, B and C. And based on our FDs, we can find these two tables are both in the BC normal form, right? Because in this table, we only have one single FD, A implies B, and A is a key for the relation, right? And we can also have this C implies B for this table, C is the key for the relation as well. Therefore, we have these two subtables, they are both in the BC normal forms. And later on, if we plan to do some queries by joining two tables together via this natural join, right? And we can recover this original table by joining two tables together with a natural join. According to the natural join algorithm, I hope you can still remember how to compute the natural join between these two tables, right? Based on the shared B attributes. And we can provide the table of the natural join at the bottom in this page. And the table will be like this. We have A, B, C as three attributes, right? Because this B is duplicated, we will only have one copy of B in the result, right? We have A, B, C as the attributes. How about data tuples? We'll combine pairwise of the tuples we show in these two tables, right? Based on the shared attributes. So in this result table, we find this table has more data tuples. Besides the three we have originally, we can create two new non-existing data tuples via the natural join. Right? So you can see this R prime we can get after recovery is different from the R we can have before the decomposition. Even though this decomposition can decompose this relation into two small relations which are both in the BC normal form, however, the relation we can recover is different from what we have before. Therefore, we can say this decomposition is lossy. Right? It is lossy decomposition. If we plan to have some lossless decomposition, what will we have? A better decomposition will be like this. Given a relation, we have A, B, C. Before we decompose the relation into A, B, B, C, right? In this decomposition, we have the decomposition like this. We have AC and BC, right? As two new relations. If we check the two relations, we find that they are both in the BC normal form, right? The first one, we don't have any FDs. For the second one, we have one single FD, C implies B. C is also the key for the relation, right? Then it should be fine. And we can further recover the original relation by doing the natural join between them via the shared C attributes. When we get this recover this R prime relation as in above, so by comparing this relation with the original relation, we can find that they're the same. Then we can say this decomposition is lossless decomposition. Right? It's different from the previous decomposition, right? And normally we prefer this lossless decomposition because it can make sure we don't introduce any redundant or non-existing data tuples in the recovery relations. Okay, so this is another decomposition we can get. This one is better than the previous one. However, we also have some problem with this decomposition as well. Because if later on we plan to check some FDs, A implies B, based on this decomposed relation, we have to do a join, right, to check them together. We have to do the join to check them. In other words, this decomposition cannot preserve all the FDs. So this is the problem we are facing right now for the decompositions. They can either introduce some loss information or they can create some problems with checking some FDs.